What is up, everybody? I said the week before last that I was going to try and nail down all the remaining parts and pieces I need for that circuit for the spindle control and get an order together. So boom, it has arrived. I only had to order like, I think it was 6 items in the cart. So that's not too bad. To be honest, it took like over a week to get here, so I don't even remember what I ordered. Right here, this is a little jack to, for your wall adapter. I'm assuming this is the wall adapter. Yep, it's a 24 volt. This thing handles 6 watts. That's a good amount of power. So wall adapter, so I can plug the board in. What we got here? LM317. So this guy can take up to like, don't quote me, but I think it's like 30 some volts, 35 volts or something. And depending on the circuitry around it, you can have an output of any voltage from 0 to not quite what you're putting in. There's a little bit of a loss, but you can adjust your voltage range. Oh boy, dip socket, 16 position. What the heck did I order this for? Maybe I'll look at it. Oh, this is a socket for the optocouplers. So that way I don't have to, like when I build a board, I can solder the socket on there and not have to solder the optocouplers directly to it. Just trying to save parts and pieces. And this looks like the optocoupler. Yep, opto isolator they call it. Boom. And what the heck is this? Oh, potentiometer, 5 kiloohm potentiometer, linear. So boom, that's what I got. The rest of the stuff is here. So I should be able to build a circuit using that. So in case you forgot, the idea is to take a pulse width in, stick an analog voltage out. So it's really only, I got 6 things here and I've got like a couple capacitors and resistors and junk over here. So that's really about it. There's not much to the circuit, so I'm going to try and lay this out. I'll show you that. Then try to get like a prototype on a breadboard, and then from there start drawing up the actual circuit board, how we want to get it printed. Alright folks, so I went ahead and put together a prototype circuit here. It's pretty sweet. So far it seems to be working, so I'll go ahead and walk you through it here. Alright, so I don't want to bore you guys with every little resistor and every little component on here. So I'm just going to kind of go through the gist of it. First of all, the Arduino up here at the top and this top breadboard, all that's doing, that's just there to provide a pulse width signal because I don't have a mill here or a computer with LinuxCNC to provide that signal. So that's all that's doing. That's not part of the circuit. The circuit is this bottom breadboard. So we've got power coming in from, let's see, can you see my hand? Yeah. So power coming in from these 2 wires, and it's going directly to the wall with that little wire. I know it looks sketchy, it's okay. I'll try not to burn anything down. So from there we've got this corner here where everything got really crammed in here. I didn't plan it out very well. But anyway, power comes in. There's a couple capacitors and resistors there. So this is a linear voltage regulator here, so it can take in anywhere up to, I think it's 35 volts. And output 1¼ volts all the way up to just shy of that 35. So right now we got 24 volts going to it, and I went ahead and added some points that I can probe. So my black lead is wired into ground. This yellow one that's just kind of hanging out is the output of that wire. And so if you probe it, like right now I've got it set to 12, and this potentiometer along with some other resistors changes the voltage. So I can go all the way from there, that's very bottom, 1.26. And then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I can keep going. The only thing is I'll probably pop that little LED that's on my board, so I don't want to go too crazy with it. Without anything hooked up, which I actually could do that too. So if I disconnect the output side of that guy, now I'm okay to crank it up. So we got 12 volts. You can keep going, 14, 18, 20, 21, 22. So I end up at like 22.2 volt output. So this is what's key. If like for the Sieg mills, they all run 0 to 12 volt input on their motor control boards. And if you have a 12 volt source, like coming from the wall, it doesn't like to give you that full 12 volts. All I could ever get was like 11 point something. And so here you can dial that in to 12. And honestly, you're gonna have to go a little bit higher than that. I'll show you here in a minute. But so right now we got dialed in 12 volts. We can send that input. So now that 12 volts is going to an optocoupler. So that's what separates this power supply from the power supply that's powering just the signal off the breakout board or your computer, however you've got it set up. So it goes through that optocoupler and then it goes on to get smoothed out because it's still a pulse at that point. So we've got a capacitor that can just charge and discharge really quickly. And that will basically keep it from being like on and off. It'll smooth it out to be more of just an analog. And then I've got one resistor in there just to give that signal somewhere to bleed off. And then right now I got a resistor and an LED just to kind of give you some visual. Back to the other side, so we've got, this would be LinuxCNC providing your PWM, and then it's going to the one side of the optocoupler that's going to pulse this thing. So the LinuxCNC is using the optocoupler just to pulse that whatever signal power supply you've got on there. So it's sitting there pulsing, and then the output is going to be this wire. So right now, remember we had a 12 volt signal, or 12 volt source. Right now we got 11.5 volts, and that is cranked to the max. So pretend you're in LinuxCNC and you turn down your spindle speed. It'll go all the way down to 1 or 0. It should go to 0. Actually, I wish it would go faster than that. I might have to play with my capacitor sizing. Okay, we're in millivolts. That's like nothing now, so it's off. And then you start cranking it. 7, 8, 9, 10. Then it goes to like 11.5. So that's where you can go back to your initial power supply and kind of just tweak that knob. And now you're getting that 12 volts that you need. So that would give you your full speed. And you can check, so what's that power supply putting out now? So it's giving out about 12.3. So you just need that little bit more headroom. But that gives you a 0 to 12 output, which that's what we need. Actually a hair more. So I'll get a better potentiometer that's not so touchy, and then it should be pretty good. It'll be one of those things that you dial in with a multimeter the first time you use it and never touch again. So maybe summarize a little bit. You've got power supply over here giving you, up to 35 volts. You dial that down somewhere in the ballpark of 12 volts for the Siegs. Some might be 10 volts, whatever your application needs. That power is fed to the one side of an optocoupler and then onto your load or your like motor control board. The other side is controlling that optocoupler is coming from LinuxCNC, and that's where you're going to feed your PWM signal. So that's pretty much the most of it. Oh, and then before it gets to your load, you've got a capacitor and a resistor in line with it so that it can smooth out the signal and change it from being PWM to a nice smooth signal. All right, so that's really all there is to it. Next up, I need to get in touch with my buddy that knows more than me, figure out how to draw up a little circuit board for it, and have a run of like 15 or 20 of those made, and then hopefully hook up to my mill, make sure it works, let everybody know, and then hopefully sell a few of these. That would be pretty cool. So it's fun to be able to create stuff, and it's really fun to be able to help other folks out that are having the same issues as me. It sounds like I'm definitely not the only one. running into this snag with spindle control. So should be a bolt-on deal. Hopefully adjustable enough for multiple applications, and should be pretty good. Thanks for watching. See you next time.